Hello and welcome back to StatLab. Today we're going to look at random variables. A random variable is a variable whose value depends on a numerical outcome of a random phenomena or chance process. It is used to calculate probabilities. In random variables, the mean is called the expected value, and we look at either the expected difference or the expected sum of two variables. So for the expected difference, we use this equation here. So we take the mean of the first thing and minus the mean of the second thing, and that gives us our mean difference. For the expected sum, we do the opposite. We take the two means and add them together to give a mean sum. Now we can also calculate a standard deviation of the difference and the sum, and that is the same calculation for both. Is the square root of the two standard deviations squared and then added together, the whole thing is square rooted. And our test statistic is going to be z equals d minus mu d over sigma d. Now, d is usually the value that the question is asking about. If it's not specifying a certain value, then you say d equals 0. What I mean by that is if I'm saying that what's the probability that A is 5 grams more than B, then I would put 5 in for D. But if I just said what's the probability that A is more than B, then I would put 0 there because I haven't asked by how much more. Let's take a look at an actual example. A particular brand of cereal contains an average of 450 grams with a standard deviation of 2.8 grams. You pour one small bowl and one large bowl. So the small bowl holds an average of 42 grams with a standard deviation of 8 grams, and the large bowl holds an average of 70 grams with a standard deviation of 11 grams. So we have our two means here and our two standard deviations. So the small is a 42 gram mean with a standard deviation of 8, and the large one is a 70 gram mean with a 11 gram standard deviation. So the first thing we're going to do is find our mean difference. So we're going to take the average from the large bowl and subtract the average from the small bowl, and that is going to give us 28 grams. So our mu d is 28 grams. Now for the standard deviation, we're going to add both standard deviations squared together, and then we'll square root to get our final answer, and we will get 13.6 grams. So now we have our mean difference and our standard deviation of that difference. Now let's answer an actual question. What is the probability that after you pour the bowls, the small bowl contains 5 grams more than the large bowl? So we use our equation, and of course I asked for 5 grams more, so d is going to be 5 grams. Our mu d is 28, and our standard deviation is 13.6. Once we calculate that and we get our minus 1.65, if we take that to the Z table, we find we have a p-value of 0.0495. So the probability of pouring a small bowl with 5 grams more than the large bowl is 4.95%, which makes sense because we wouldn't expect it to have a high likelihood of happening. So let's say now that I wanted to look at a sum instead of a difference. So what is the probability that the total amount poured into both bowls is greater than 125? So now I need a mean sum instead of a mean difference, so we add them together instead of subtracting, and we find that it is 112 grams. But again, we're going to use our same equation. We have 125 grams minus 112 grams divided by 13.6, and that gives us a z-score of 0.96. Now, when we take this to the z-table, we're going to need to minus it from 1. So in this case, we find 0.1685. So that means that the probability that the total amount poured into both bowls is greater than 125 grams is 16.85%. Suppose now that I wanted to know what is the expected value of cereal left in the box and the standard deviation. The question did tell us how much cereal was in an entire box, and it also gave us a standard deviation for the box itself, so we do have the information we need to solve this. So the expected amount left in the box should be the total mean minus the mean of the sum. So that would be the 450 grams minus the 112 grams, which gives us 338 grams. Our standard deviation for what's left in the box will be the sum of those deviations squared. So we have 2.8 squared plus 13.6 squared. Square rooted gives us 14.2. So the expected amount of cereal left in the box is 338 grams with a standard deviation of 14.2 grams. So I hope this video helped you make sense of random variables. If you liked this video, go ahead and hit like. And if you'd like to see more videos like this, hit subscribe. And in our next coming video, we're going to start looking at linear regression. And linear regression is a topic that a lot of students in intro statistics struggle with. So I'm going to break it down into a couple videos so to not put too much information all at once. So if you're interested in that, keep a lookout. That video will be coming soon.